Do you have the quiz open, Brad?
Okay. Since lesson 12, homework 2 on October 29th, you were able to see those answers on October the 30th.
We'll be able to?
Yes.
Oh, when did he say that?
It was yesterday at 4:11 my time, 5:11 his time.
Gotcha.
Hey guys,
Hey, welcome, CJ. We're just about to get started.
the original call woke me up from my nap, so
Oh,
took me
gotcha.
a second to get on.
Not a problem at all.
So lesson 12 group meeting quiz, correct?
Correct.
I saw a thing that he sent to you that he cannot hear last week.
Yeah, I saw that. Not sure what that is.
So what now?
He just couldn't. The audio is not. It didn't work on our last week's recording for some reason.
Oh, that's weird.
Let me know when everyone's there.
All right, I have everything open.
I'm open.
Awesome. Okay, so for number, I'll go ahead and read number 3. It says, suppose we have a set of paired data, and that D equals X after minus X before. The null hypothesis is that mu equals 0. The alternative hypothesis is it's not equal to 0. The population classification, no, it's not that. Jordan collects a sample size of n equals 9, and computes that D equals 2.2, and S D equals 3.3. So it's asking what the best statistic is.
Is it 2.2 minus 3.3 divided by 3?
think you're close. Sorry. My brain is waking up.
No problem. I was just going to use the Excel sheet. Is that not what you guys would do?
What would you use on the Excel sheet?
I guess I'm thinking of the two. Let me see if that works for this one.
Is it 2.2 minus 3.3 divided by 3? That's what I'm guessing.
So I think it's 2.2 divided by 3.3 divided by the square root of 9, which is 3.
The 2.2, I think it's 2.2 divided by 3.2.
Daniel, you're kind of cutting out.
It's the answer to
You guys agree with my answer?
it's the answer to
0.222.
is it two?
Are we on question 3?
Yeah.
Welcome.
Is it negative 0.367?
No, it was 2.
Yeah, I got the value of 2.
You guys got 0.222. Is that what you got?
No, just 2.
2. So it's our 2.2 divided by 3.3. And then
Yeah.
times that by the square root of 9, because the denominator is divided by the square root of 9. So times by 3 is the easy way to do it.
Oh yeah, I actually haven't done that, so that makes sense. But now I have to. I didn't multiply. I divided the last time. So who wants to do number 4? Read number 4.
For me,
Yeah, sure.
the probability of saying a test statistic greater than Jordan's test statistic is 0.0403. Use the probability to determine the p-value for Jordan's hypothesis test. Do we use the normal probability app? Am I getting 0.3435?
This one's a lot more simple than you would think it is.
Is it as simple as I think it is?
It's as simple as you think it is.
Okay. So the answer is 0.040?
No,
Okay, then it's
not that simple.
Darn it.
So you're going to use the probability applet.
Okay.
You're going to enter it in, and you're going to use just the greater part. I don't know how to explain.
Is it
Hold on, I got a pull.
0.435?
I think that's close. One second.
Just the greater part you guys said? What number are you putting in the app?
Yeah, you're going to put 0.403 or 0.0403 into the applet.
Into the area section?
And get our z-score, or our,
I got 1.747. As the z-score. Is that what you guys got?
yeah, that's what I got plugging it into the applet. That doesn't make sense to me using as a
Student,
key
the
value,
T
though.
student. I think you're going to do the T student one, though. Either that or I'm totally leading you astray and I don't know what I'm talking about.
Is it 0.484?
No.
Okay.
Is it 0.344?
So I have, with 8 degrees of freedom, since we have 9 sample size, an area of 0.0403. And the area to the right gives a t-score of 1.999.
Is that for number 4?
Yeah, but I'm not sure if I'm doing that right. It seems to be what the book says, but I'm not sure.
Which section are you finding that in the book?
What I've done is more just inferring it. I'm not finding anything specific in the book.
Because I did the number probability app. I plug in 0.403. Is it 0.344? That's greater than 0.
How many degrees of freedom are we working with again?
8 degrees of freedom.
Is number 4 1.999 for the answer?
I think it's half of that. Does that make sense?
All right. Suppose we have. Oh, it's double. It should be 0.081.
Yes.
That makes sense. So it is as simple as I was thinking. I was just not doing all this stuff. Okay.
Can you explain what you did to do that?
Yeah. So the in our T probability applet, we have students' probabilities with 8 degrees of freedom because we have a sample size of 9, and our degrees of freedom is our sample size minus 1. So that is 8. And then we have our T value, or our test statistic, which is 2.000, which was our answer to number 3. So we plug that in for our T. And then our hypothesis test is not equal to 0. So we shade both the top and the bottom parts, or both left and right tails. And that gives us our answer of 0.085.
In the area, right?
Yeah, the area of our two tails.
Okay,
Now-
yeah, that's right.
Now, the easy way to do this is to realize that if the test statistic is greater than Jordan's test statistic is 0.0403, then that's only one of the tails. And when you're taking the measurement of both the tails, it's just that value doubled. And so you have 0.0806, which rounds up to 0.081. Does that make sense?
Yeah, that makes a lot of sense.
Is it 0.081?
Yep,
Just double that.
pretty much.
Because I was doing the normal probability applet. That's all I was doing.
Yeah, we can't use the normal probability applet for this because we have the t value thing that we're doing. So if we
Can you
use
see
the
my
normal
screen?
probability,
Brad? That's what you type in on the normal probability applet, or the student's T probability applet. You've got 2 in the T equals 2, and then you have your 8 degrees of freedom, and then your area comes out as 0.08, and then you get it down to or it rounds up to 0.81. 0.08.
Where is the 8 degrees?
That's the area of your two tails.
Okay. On the normal probability applet.
We're ready to do the next one. I have that one if you guys are ready. Did you guys get 0.407 for number 5?
Let's see. 0.407.
Yep.
For number 5?
Yes. You just put it into the Excel sheet, the data, you copy it and paste it in there.
Is it 0.470?
Yep.
0.407.
Yeah, that's what I meant.
Is it that one?
I can't see your screen, but I just messaged this.
Is it that? Is it that for the answer?
We can't really see your screen, to be honest.
Okay. Can you see it now?
0.407.
Now we're just seeing the title of the page. Can you see
Title.
the text chat box, Brad?
No. Is it 0.470?
407.
0.407.
0.0. Is there zero? 0.047?
Have some recursion if you look on my screen. Oh, let's not do that.
Okay. For the next one, I got 0.689.
Yep.
And based on that, I got that we rejected them. No, I always mess up the order.
Yeah, we failed to reject the null. So,
Because it's greater than?
yeah, because it's greater than.
1.
Greater than the p-value.
What's that?
Because it's greater than the p-value. Or than the levels degree. Right?
Is number 8 B? B or D?
I would say B. We have insufficient evidence to prove the hypothesis.
Yeah.
D for golf.
B for boy.
I was right on that one. I guess on that one.
All right.
Hey, Brad, are you understanding how to use the Excel document?
That. Are you talking about the map? Are you talking about the map?
I just want to make sure that you understand how to use these, just to make sure you're successful on your homework. I know you, these are going to be helpful, and I'll be grateful for you. If you have any questions about how to use Excel, please.
The only problems I have is the map part. which formula I use. I was using the number app for question number 4. That's why.
Okay. Well, let us know if you have questions. For number 9, I got that n is bigger than 2x in the computer.
Yep. That makes sense.
And then I got that the p-value is 0.001.
Yep.
Did I change that one? Level of confidence is for this one? I didn't change that.
Also reject the norm hypothesis.
It wasn't changing it ahead.
I would say fail to reject, partially because our p-value is 0.012, but also because it's not less than, it's at the level of significance when we round.
Yeah, I agree with you.
Is number 12 increase number 12?
Well, that's actually something I didn't change in my thing.
The p-value would decrease. Because instead of using both tells, you're now only using one.
So in this case,
Is number 13 reject the norm hypothesis?
For 13, yeah, I believe so.
reject the norm.
Is number 14C?
I don't know. I don't like question 14 because it doesn't really match with the previous question. And Will, if you have any clarification, let me know, but your mic is muted if you've been talking. But based on the previous question, I would say we have sufficient evidence to show that
There is a
the
difference.
value is greater than, not that there's a difference.
I'm pretty sure it's that there is a mean difference between the two groups.
There is.
Yeah, that's what I thought was C.
Okay.
That one got my other group as well.
Is it for that same reasoning I stated that?
Is it C? C for cat?
Yes.
Because that answer seems like it's in the form of the not equal hypothesis statement instead of the greater than hypothesis statement, which question 13 gives us, right?
Is number 15B the boy?
I'm sure he's doing that.
Are you on 15 now?
Yeah. This one doesn't make sense to me because I'd think it would be both either less than, or mu is less than 0 or mu is greater than 0. But we can only select one.
Oh, I'm sorry. So 15 is not enough information.
Okay, it does depend on the problem.
Yeah. This is a lot like the last lesson, these last 4 questions.
Okay.
I'm sorry, I don't, for that one, are we just shooting in the dark? Or do you guys feel pretty good about what you wrote down?
I'm kind of trusting Will on this one because both B and D seem like they'd be the same answer.
Yeah.
And
So
so
I didn't hear what the one that read it said.
but there's not enough information, and it depends on the problem.
That makes sense. So determine the 95. So the 95, the point estimate?
That's the point. Hmm. That's the point.
So what is the point estimate for this 95% confidence interval? I believe that would be 11.955.
11.9.
So to calculate that, you're just using the formula that's
Is it the
It's
group 1, group 2 at the very top?
chapter 10 under 3 point, yeah, under 3.
So for question 17, we have our confidence interval between 5.303 and 18.607, right?
For number
Yes.
16,
Yeah. Well, all these 16 through 19, we have that confidence interval, right?
0.95, yeah.
Wait,
The
what?
confidence interval is 0.95 is what you're saying, right?
No.
Isn't that what it says right there?
It's asking for what is the point estimate for the 9.95 confidence interval.
Gotcha.
So what is the point in the middle that we're based off of on both sides? And so I just added the lower and the upper bound and then divided by 2 to get the number right in the middle, and that's 11.955.
Oh, gotcha. You're right.
And then to figure out the margin of error, you use 11.955 and either subtract that from 18.607 or subtract 5.303 from that.
Oh, well, and Excel actually already does this for us.
What's that?
Excel actually does this for us with this data.
Oh yeah, there's the mean. There's the 11.995. Where is?
Margin of error.
Yeah.
Is it negative 7.94?
Because for the margin of error, I got 6.652, but I'm not seeing that on the spreadsheet.
Yeah, it doesn't calculate it. Yeah.
Okay, yeah, so it gives us the mean.
Is it 6.920?
Not 6.652.
6.652.
Yeah. And then I got for number 18. I got 18. Excuse me. 18 is 5.203.
Yep.
And 19 is 18.207.
Yeah.
Okay.
Can you go back? Okay, tell me if I'm correct. Number 3 is 2. 4 is 0.081.
Yep.
5 is 0.047. Is that yes?
Number 5 is 0.407.
Why is, okay, well, what happened when? Why didn't? Okay, 0.047. Number 5.
TJ, did you already submit yours?
I did.
Did you miss anything?
Question 11 we missed. We reject the null hypothesis instead of fail to reject it.
Anything else? That's interesting.
Nope, everything else we did good.
0.047 for
You
number
got it.
5.
The answer was texted to you, Brad. 0.407.
I can't get. Let's see. How can I get? Because I'm using my cell phone.
It's 0.407. You're adding an extra 0 in there. It's 0.407.
Okay. Is it 0.47?
One moment.
Okay.
All right. See my screen? 0.407.
Oh, that's me 0. And number 6 is 1.239.
So did I understand it that we're not doing the other lessons yet?
Um,
How can